Welcome back to the deep dive. We are incredibly glad you're here
Yeah, absolutely.
because we know exactly who you are. You're the kind of person who really loves to learn, who constantly seeks out multiple perspectives, and who really lives for those satisfying aha moments.
But you definitely don't want to be bogged down by, a massive wall of dense academic jargon.
Exactly. You want the deep insight without the overwhelming information overload. And well, today we've got something truly special, custom tailored just for you.
We really do.
We are looking at this massive, highly ambitious stack of notes and theoretical excerpts exploring a concept called gravity as emergent relational coherence geometry.
Yeah, I know.
That title is an absolute mouthful.
It really is.
But our mission today is to explore a completely radical, mind-bending reframing of reality itself. We are going to look at a framework where space isn't a container, time isn't a fundamental property of the universe, and gravity is actually just an illusion created by relationships.
There's a lot to take in.
I am practically buzzing with natural enthusiasm for this one because this is a huge paradigm shift. It completely changes how we think about the very room you're sitting in right now.
It really does. And my intent today is to help us navigate this paradigm shift smoothly. We aren't just going to explain what this theory says on a surface level. We're going to carefully look at why it matters, how it actually functions mechanically, and how it connects to the bigger picture of physics.
Right.
Because when you strip away our everyday assumptions, the underlying architecture of reality starts to look completely different, yet somehow infinitely more elegant.
Okay, let's unpack this by actually starting with what we already know. Because to understand why this new framework is so radical, we have to establish the traditional Birchline, right? Which is the Einsteinian view of gravity.
Right, the baseline.
Now, most of us grew up thinking of gravity as a Newtonian pull. You drop an apple, the earth pulls it down, it's a force.
Yeah, the classic invisible string.
Exactly. But Einstein came along and said, no, that's not what's happening at all. Gravity isn't a pull. It is bodies following the straightest possible paths, which physicists call geodesics, in a curved space-time geometry.
Right.
The notes give us this really clean, brilliant one-liner to sum it up. Mass energy tells space-time how to curve. Curved space-time tells matter, and light how to move. The geometry itself does the steering.
Exactly. And locally, you only feel what we call weight when something actively prevents you from following that natural, straight path through curved space-time.
Okay, so
Like when you stand on the ground is literally forcing you off your geodesic. It's pushing up against you. That's what you experience as weight.
got it.
In Einstein's view, the geometry of space and time is fundamentally merged into one unified fabric, and that fabric is warped by the presence of mass.
Right. But here's where this new theoretical framework makes a completely bold, radical pivot. It takes that classic Einsteinian concept of space-time, and it essentially tosses the time part right out the window.
It really does.
It argues that time is not a fundamental aspect of gravity or reality. It suggests that time is entirely subjective, that it is merely the unfolding of space.
Yes.
To this framework, space is the primary thing, and time is just a way we perceive the changing of that space. Now, I have to push back a little here because on the surface, throwing out time sounds almost like science fiction.
It does sound a bit out there.
Right. Like, if time isn't a fundamental reality, why do my knees ache more today than they did yesterday? Time certainly feels real to me.
That is the perfect question to ask, and it's the exact hurdle physicists face when approaching this. What's fascinating here is that this seemingly wild idea, demoting time, is actually grounded in very real, established physics frameworks.
Okay.
To understand it, we have to look at the 3+1, or ADM, viewpoint.
Okay, ADM viewpoint. Walk me through that. What does that actually mean?
Sure. In standard general relativity, you often picture the universe as a giant, frozen, four-dimensional block of space-time. Past, present, and future all just exist in this block.
Okay, I'm picturing a big block of ice.
Right. But the ADM formalism, named after the physicists Arnowitt, Deser, and Misner, slices that block up. Think of an MRI scanning a human body, capturing it slice by slice. Or better yet, think of a movie.
Like a real film.
Exactly. A movie isn't a flowing river of time. It's a stack of individual three-dimensional frames.
Oh, I like that. So reality is just a series of 3D snapshots.
Precisely. You treat the universe as a sequence of 3D spatial slices. It's a 3D geometry that updates frame by frame. And in that highly rigorous mathematical framework, what we call time is treated simply as an ordering parameter.
An ordering parameter.
Right. The equations use variables called the lapse and the shift. If the 3D slices are the frames of the movie, The lapse and shift are just the literal crank turning the projector, telling the geometry how to update from one frame to the next.
Wow.
The geometry of space is the primary physical object. Time is just a bookkeeping label to keep the frames in order.
So time is just the index number on the file folder. It's not the stuff inside the folder.
Exactly. And there was another known program in physics called shape dynamics that backs this up. Shape dynamics explicitly trades the usual rules of spacetime for something called 3D conformal invariance.
What means?
It means that the fundamental reality lies entirely in the angles and the shapes within a 3D space rather than a 4D spacetime block. It proves you can do all the heavy lifting of gravity's mathematics with a space-first perspective.
That's incredible.
Yeah, it treats the whole problem of time in physics as a major clue that time simply isn't fundamental in the way we've always assumed.
It is so wild to think about, but if time isn't fundamental, it forces us to look really closely at space. And this framework doesn't let space off the hook either.
Not at all.
It completely redefines it. The idea that space isn't a pre-existing stage or an empty container that things sit inside of is just a marvel to me.
Yeah.
Because if space isn't a container, what is it?
Right.
The core thesis we're looking at states that space is relational informational coherence outside of energy and time.
Let's break down that coherent substrate methodically, because it is the absolute bedrock of this entire deep dive.
Yes, let's do it.
Picture reality not as an empty box, but as a vast, dark network of elements or events. In this network, the foundational layer is not physical distance.
Okay.
The absolute base reality is a coherence value, which is represented mathematically as C sub ij. This value exists between different degrees of freedom in the network. It is essentially a measure of how strongly connected or mutually constrained 2 points in the network are.
Okay, so the math in the notes actually gives us a formula for this, right?
It does.
It says distance equals negative lambda times the logarithm of the coherence value. Now, I'm not going to pretend I do logarithms for fun on the weekend, but let me see if I can translate this into something we can all visualize.
Go for it.
If distance is the negative log of coherence, that means high coherence equals a small distance, and low coherence equals a large distance.
Got it perfectly.
So it's basically like a social network. Think about your best friend. They might live 1,000 miles away physically, but in your relational network, you text them every day, you know what they had for breakfast, they are highly coherent with you. Right. So in this informational geometry, they are close. Meanwhile, a stranger who literally lives in the apartment next door who you've never spoken to has very low coherence with you.
Yeah.
So in the network, they are far. Space is just the pattern of adjacency. It's what is near what, based entirely on how strongly they communicate.
That is a phenomenal analogy. Space is an information geometry. And if space is just this reconstructed pattern of relational coherence, it radically redefines the roles of energy and time.
How so?
Well, energy is no longer a physical substance floating around. It's simply the cost function. It's the action required to change this relational configuration.
Oh, I see.
If you want to alter the network of connections, if you want to make that stranger your friend, it costs energy. And time, as we touched on earlier, is totally demoted. It is just the ordered count, the phase, of those reconfigurations. An index of updates, nothing more.
Here's where it gets really interesting. So we have to ask how these connections actually behave. What does this coherence look like mechanically? It's not just a binary switch, right?
Right, no.
It's not just on or off. The framework describes it as a reciprocal phase relationship.
Yes, and to capture that continuous reciprocal nature, we use complex relational phasor math. It sounds incredibly intimidating, but it breaks down beautifully into two distinct parts.
Breakdown.
Imagine the coherence between two nodes as a complex phasor. First, there is the magnitude, or the strength of the relationship, denoted by the Greek letter rho. This is simply how robustly the two things remain mutually related. Are they barely whispering to each other, or are they shouting?
Okay, strength makes sense. What's the second part?
The second part is the phase angle of the relationship, denoted by the Greek letter phi. This dictates how they relate. To visualize phase angle, imagine two heavy pendulums swinging back and forth.
Okay, pendulums.
If they are swinging in the exact same direction at the exact same time, they're in phase. Their angle is 0. If one swings left while the other swings right, they're exactly out of phase.
Like opposites.
Exactly. That's a 180-degree difference. They could also be leading or lagging each other by 90 degrees. And crucially, this relationship is reciprocal.
Meaning it goes both ways.
Yes. If pendulum A relates to pendulum B with a certain strength and phase, pendulum B relates back to A with the exact same strength, but with the opposite phase angle.
So it is truly a tightly coupled two-way street. But
Yes.
having a few swinging pendulums doesn't instantly create the massive, stable 3D universe as we know it, right? Because there is this brilliant concept of the threshold. Space isn't always on.
That's right. Below a certain threshold of consistency, you just have a jumble of relationships. You have pendulums swinging every which way. You don't have anything that resembles the stable geometry we call space.
Right.
Distance simply isn't well defined yet. The magic happens when the network of relationships becomes highly consistent. The specific mechanism for this is called loop closure.
Tell us about loop closure. How does a loop close?
Imagine three interacting nodes in this network. We'll call them Alice, Bob, and Charlie. Loop closure occurs when the phase angles between those three nodes add up perfectly to zero, modulo 2 pi.
Okay, hold on. Modulo 2 pi. Let's unpack that for a second.
Think of a standard 12-hour clock face. If it's 2 o'clock and you add 12 hours, you are right back at 2 o'clock. The clock face resets.
Right, it goes around in a circle.
In phase math, a full circle is 2 pi radians, or 360 degrees. Modulo 2 pi just means that if the phase shifts add up to a full circle, they effectively reset to zero. They are perfectly aligned again.
Wow.
So loop closure means Alice's relationship to Bob, plus Bob's to Charlie, plus Charlie's back to Alice, perfectly completes the circle without any leftover contradiction.
So they all perfectly agree with each other.
Exactly. And when lots of these loops close across the vast network, the phase frustration, the chaotic disagreement in the system, drops to almost nothing.
Wow.
The network achieves global self-consistency. Only then, at that critical threshold, does a stable, low-dimensional geometry emerge. That is when space turns on. Space is the compressed, coarse-grained shadow of all those perfectly consistent relational loops.
It's exactly like the moment a magic eye picture finally snaps into a 3D image.
Yes, perfect analogy.
The underlying pattern of ink was always there on the page, but the space, the depth, only emerges when your brain finds the consistent mathematical relationship between all the dots.
Exactly.
And what's incredible is how looking at reality this way effortlessly explains major quantum mysteries. Let's tackle quantum entanglement.
Let's do it.
For decades, physicists have pulled their hair out over entanglement. You take two particles, you entangle them, and you send one to Mars and keep one on Earth. If you measure the one on Earth, the one on Mars reacts instantaneously.
Right.
How can they be completely connected forever, reacting instantly, without any physical space between them to carry a signal?
This raises an important question. What if we've been fundamentally misunderstanding what distance actually is this whole time?
Okay.
Our analysis of entanglement through this framework completely flips the script. Entanglement doesn't mean there is no space between the particles in some spooky, magical way. It means that spatial separation, geometric distance, limit signals, but it does not limit correlations.
Oh, that is a huge, huge distinction. Let's linger on that.
Let's use our Alice and Bob analogy again.
Okay.
Imagine Alice and Bob are entangled particles.
Right.
If Alice wants to send a brand new message, a signal to Bob, that signal has to slog through the emergent 3D geometry.
It has to travel through the network.
Right. It is limited by the speed of light. But their correlation, their intrinsic shared phase relationship, doesn't have to travel at all. Entanglement is direct, glaring evidence of a relational linkage that simply isn't parameterized by geometric distance.
Wow.
It proves that geometric distance is not the most fundamental notion of closeness.
So even though Alice is on Mars and Bob is on Earth in the 3D magic eye picture and the underlying coherence graph, they are directly adjacent. They share a highly robust relational phase. They are literally right next to each other in the base reality.
Precisely. The geometric space is just an illusion laid over top of that true adjacency.
Okay, if that explains entanglement perfectly, how on earth does this framework handle wave-particle duality? The fact that a photon can act like a smeared-out wave 1 minute and a solid little particle the next.
It's the exact same logic, and it provides an incredibly elegant solution.
Yeah.
It all comes down to the coherence topology. What we call wave behavior is simply what happens when relational coherence spans multiple alternatives and remains globally consistent. Because the phase relationships are maintained smoothly across the network, you get interference patterns. That's all a wave is, smooth, distributed coherence.
And a particle.
Particle behavior happens when that coherence becomes locally pinned to a specific node. The alternatives become distinguishable, the smooth cross-path phase relations break down, and the interference collapses.
It collapses.
Exactly. It is the exact same underlying entity. It hasn't magically transformed from a liquid to a solid. It's just operating in a different coherence regime within the network.
So what does this all mean for our everyday lives? If space is an emergent web of coherence and time is just an update index and particles are just locally pinned coherence, what are physical objects?
Right, the real world stuff.
Yeah, what is the coffee table I keep stubbing my toe on, and what is gravity? The framework gives us a fascinating definition here. It says that matter is a persistent relational motif.
I love that phrase.
Me too. So when you stub your toe, you aren't hitting solid matter. You are smashing your foot into a stable knot, or a defect in the coherence fabric that aggressively resists being smoothed out. It's a localized tangle in the network.
Exactly.
And gravity. Gravity is simply the bias in geodesics caused by this inhomogeneous coherence structure. The straightest paths through the network are deformed by these knots of matter. It's not a pull. It's just the network bending around a tangled knot.
If we connect this to the bigger picture, though, we absolutely have to issue a crucial scientific reality check.
Okay, let's hear it.
Because theories like this can sound wonderfully poetic, like matter's a persistent motif, but they have to survive the brutal, unforgiving test of objective reality. Even if this theory claims time is just an emergent update index, it still must account for the objective, measurable behavior of clocks in the real world.
Right, because gravity affects time. That's not theoretical. That's a proven, measurable fact.
Precisely. You can't just wave that away. GPS satellites orbiting the Earth have to constantly correct for gravitational time dilation. The clocks on those satellites run faster than the clocks on the ground.
Because they're further away from the mass.
Yes. If they didn't correct for it, our navigation systems would fail entirely in a matter of minutes. And the National Institute of Standards and Technology, NIST, has literally measured height-dependent clock rate differences at everyday scales.
Everyday scales.
Yeah, they've shown that an atomic clock sitting on a shelf runs at a slightly different, faster rate than a clock sitting on the floor, just because it's further from the center of the Earth. Any viable theory of gravity has to explain that phenomenon.
So does this relational coherence framework survive that test? How does it explain clocks ticking differently if time isn't a fundamental dimension?
It survives beautifully.
Yeah.
It survives because these rate differences can be interpreted without making time a fundamental substance. Instead, they are interpreted as geometry-driven unfolding rates tied directly to the spatial geometry.
Unpacking that, you mean the density of the network changes how fast things update?
Exactly. The density of the coherence network, your proximity to that dense knot of matter like the Earth, dictates the local rate of relational updates.
Okay.
Near the floor, the coherence network is denser, more tightly tangled by the Earth's motif. Therefore, it takes more computational effort, more energy to process an update, so the local phase updates happen slower.
That makes so much sense.
Right. What we perceive as time slowing down near a massive object is actually just a decrease in the relational update rate caused by the sheer density of the local coherence network.
That is incredibly tight mathematically. It doesn't break known physics. It doesn't say Einstein's equations are wrong. It just reinterprets the exact mechanism running underneath them.
That's the hallmark of a great paradigm shift. And we should point out that this geometry from information approach perfectly aligns with some very serious cutting-edge lines of modern theoretical physics.
Like what?
Well, there is Mark van Ramsdonk's work, which explicitly explores building spacetime entirely out of quantum entanglement. There is holography, specifically the Ryo-Takayanagi relation.
Which it is.
It's a mathematical formula that maps quantum information, specifically entanglement entropy, directly to the geometric area of surfaces in space. It literally proves that information and spatial geometry are two sides of the same coin.
Wow.
And then there is causal set theory, which strips reality down to discrete dots of events and derives continuous spacetime as a large-scale approximation, very similar to our network threshold. This isn't just fringe philosophy. It is the bleeding edge of theoretical physics converging from multiple directions onto a single idea.
Okay, we have covered an immense amount of ground today. Let's do a quick summary of the massive paradigm shift we've just explored. According to this framework, reality is fundamentally a relational coherence network.
Right.
Space is not a container. It is the stable 3D geometry that gets reconstructed, like a magic eye puzzle, only once those network relationships cross a threshold of consistency.
Exactly.
Gravity is not a pulling force. It is just how that emergent geometry steers motion around dense knots of connections. And time. Time is just the index of updates, the crank turning the projector, keeping track of the changing network.
And why does this all matter? Beyond the sheer philosophical beauty of realizing you live in a web of coherence, the practical applications are profound.
Absolute.
This theory unifies gravity, quantum entanglement, and wave-particle duality under one single variable, coherence topology. But most importantly, it gives us a new control knob.
A control knob?
Yes. If coherence is the primitive layer of reality, then manipulating coherence, rather than trying to manipulate mass or force directly, becomes a direct route to shaping geometry-like behavior.
That is wild.
This opens up unbelievable pathways for advanced quantum computation, entirely new types of sensing, and potentially engineering gravitational analog systems simply by controlling relational information.
It turns reality into an algorithmic engine that we might one day learn to actually program. Thank you so much for joining us on this deep dive. As always, we want to leave you with a final, slightly mind-bending thought to mull over or explore on your own, building on everything we've talked about today.
Oh, this is a good one.
If where you are in the universe is just an emergent property of how consistently you relate to everything around you, what happens to your personal geometry when your connections begin to change?
Yeah.
When your literal informational relationships to the universe shift, do you physically move through space? Or does the universe simply redraw the map around you? We'll leave you to think about that one. Until next time.